Uh, I'd like to briefly introduce you to OpsAgility. We are the global leader in Microsoft Cloud readiness, and we offer multiple self-paced on-demand classes focused on Microsoft Azure, Office 365, Dynamics CRM, including classes for Microsoft certification exam preparation, among many more. And we are constantly adding to our courseware. We also provide instructor-led training, both in-person and virtual, ranging from enabling your sales team to sell cloud-based solutions to deeply technical training for IT professionals, data specialists, DevOps, and of course, cloud developers. Our newest offering is the OpsAgility Cloud Sandbox. The Cloud Sandbox gives you the ability to provide controlled access to Azure for testing, development, or training for an organization of any size. You may go to our main site to schedule a demo with our team to show you the incredible benefits this product has to offer your company. Do you need help with moving your organization to the cloud? Our readiness planning can help by identifying the skills gap within your company by utilizing our customer success team and senior cloud architects to help identify needs and create a customized strategic plan to ensure your readiness budget is invested wisely and efficiently. And of course, with our online learning platform, you have access to managing all your learning. We offer full support for team-based learning management as well as customizable learning paths and tracks, as well as full reporting and tracking features on your users' access, progress, and more. So why OpsAgility? Well, the numbers speak for themselves. We have already trained over 10,000 students with OpsAgility in 2016 alone with our resources. Lastly, here's a list of some of the virtual open enrollment courses we're currently hosting in the upcoming month to meet some of your education or exam certification needs. The Azure Jumpstart Big Data Developer, or IaaS, on May 25th. Designing and Implementing Big Data Analytics Solutions Exam 475, which is June 5th through the 9th. Architecting Azure Solutions Exam 7534, July 10th through the 14th. And just a heads up, we are offering you a 30-day free trial of our online training service with the promo code TryOpsAgility, all caps. Additionally, you can take 15% off the course price on those open enrollment courses I just mentioned with the promo code OPSWEB15, all caps, just for watching this webinar. If you're a business and you want to try our services out for your company, contact us by phone number provided, or email at sales@opsagility.com to schedule a demo of the service, and we will set you up with a 30-day pilot for your team. Thank you. Jen, it's all yours.
Hello there, everybody. Thank you all very, very much for attending today. Now, I'm just going to double check that you can see my screen. So my screen should just be appearing. Right, so I need to show the other screen, the one with the things on it. So there we go. That's better. We should all see Azure ML. So what I'd like to do today actually is I want to talk to you a little bit about the why of Azure ML. What I'd like to do ideally is give you some background into why Azure ML is useful. Now, I want to also talk to you about how do you choose which model you actually want to show in Azure ML. It's the question that I get asked most often when I teach Azure ML, and it's something that my customers often ask as well. So I think with that in mind, what I'd like you to take away from today is how would you make Azure ML actually useful in your business? And I'd like to explain to you why we choose certain models over the others. And then I'll take you through a quick demo which will show you a neural net. Now, you'll be able to see that there is a small question tab, hopefully, and if you have any questions as we go along, please do ask me. I'm very happy to take questions at any point. And with no further ado, I'll start to get on with it. So now, what I want to do is, we've only got 1 hour, and I'm basically want to try and help you within this hour to have as much information to go away and look at and identify as much as possible. Now, what I recommend you do is you open a browser and you Bing search for the Azure Machine Learning Algorithm Cheat Sheet. Now, you can download this as a poster and you can download it as a PDF and keep it on your machine. But what this is trying to do is give you a shortcut to help you to see how you can use Azure ML. Now, Azure ML is all about machine learning. Machine learning is something that usually comes after a successful business intelligence implementation. What customers sometimes ask me is they'll say things like, how do I get a neural net? How do I make one in my organization? But there's really no point in starting to create a neural net, for example, or any sort of funky algorithm if you don't already have very good data in place already and sound data. The data itself should be as robust and clean as possible. We have a saying in data warehousing which basically says how garbage in, garbage out. And the thing with that is, it's very, very true. If you are basing your data models on something which is not using good data, then you're not going to get good results out of it. So the point of the algorithm cheat sheet is it's already produced by Microsoft. You can see the details at the bottom. Is that it's trying to ask you to identify what is the business question that we are trying to use with Azure ML. Basically, it's saying, what do you see as a successful Azure ML implementation? What do you think it gives you? So the way that we try and work that out is to identify the business question. What is it you're trying to do? And how do we distill that down to one main data question? So if your data question is something like, how do I find unusual data points? Then that's something that we call anomaly detection. I'm not going to go into detail into these particular models right now. It's something that we're going to cover throughout this hour. But if you're wanting to know how can I find outliers, which algorithms in Azure ML should I use? You can see we've already got some here. If you want to discover structure in the data, then we can look at some clustering algorithms, and I want to talk to you about those. But essentially what they do is they group the data. So you may find that groups or patterns of fall in from the data. So let's pretend for a moment that you have a population and some people you know are voting for Democrats and others are voting for Republicans. So you might be able to find some structure in that data that separates people quite neatly into Democrats or to Republicans, or perhaps into people who are don't know voters. So you may want to use Azure ML to help you to predict the world. Now in business we are often dealing with uncertainties in the data. And Azure ML gives you a number of algorithms that will help you to identify finding categories in the data. So we can see here we've got two-class classification or multi-class classification. So if you have something like two-class classification, what that really means is you're trying to say, is the answer going to be yes or no? If it's a yes or no, for example, if it could be one choice or the other, then that would be a two-class classification. So you may want to simply classify people into high or low earners. If you want to try and classify people using a different number of potential answers, then that would be a multi-class classification. You don't actually know what the output is going to be for either of these, but your target is either two-class or it's multi-class. We've also got regression as well, and what regression is trying to predict values. You may want to do that, for example, with stock prices. It's a supervised learning algorithm, which means that you pretty much know what the outcome is going to be. It's going to be a prediction. If you get unsupervised learning, that means that you really don't know what the outcome is going to be. It's not going to be price, for example. It could be something else. You can also, when you're classifying data, you can use classification algorithms for predicting data. Say, for example, you want to classify images as depicting either a cat or a dog. If there's only two choices, we have our two-class classification method. So if you try and keep those in your head, really, try and first of all identify what the business question is. And once you have that, it becomes so much easier to work out what your algorithms might be. Here's another bit of a cheat sheet as well. Now what this is, it's trying to show you some of the potential opportunities for modeling your data that you find in Azure ML. So what we see here in the middle is we have what Azure ML actually looks like. So first of all, we are importing data, we're processing the data, we're splitting the data in some way, and then we are training the model. And what that really means is we're trying to find patterns in the data that we can repeat. For those of you that are familiar with business intelligence, you already have this structure in your brains already. It's what you do all the time. You import data, you extract it from somewhere, you transform the data into a much cleaner, shinier output. And once you have your clean data, you tend to then put the data into a data warehouse or perhaps an analysis services cube or something like that. Once you've done that, you tend to visualize the data. So you might produce some reports or something like that. The process for Azure Machine Learning modeling is not that much different actually. What you do in machine learning and obviously in Azure ML is you import data and then you start to pre-process that data. That can mean that you clean the data, you're trying to clip outliers for the data. So say for example you've got a population of data which contains data about people. And when you look at the data you've got about people, you can see that sometimes the age group is shown as being over 90 years old. Now because it's dealing with over 90-year-olds, you think, well, that doesn't make any sense. Those must be outliers. You can actually remove those from the data set in Azure ML. We also split the data. This is something that we don't tend to do in business intelligence, but what that really means is we are splitting our data into a test set and a training set. In data science, what we do is we train the data using a training set of data, and then we use a smaller subset of the data to do some testing on the model. What we're trying to do there is to check for the longevity or the robustness of the model. We're trying to make sure our model isn't working so perfectly that it cannot handle additional data, different types of data that we give it. We know that in the world we have lots of different types of data, and we live in an environment where our data changes constantly. So with that in mind, we can split the data into a test and a training set, and that helps us to work out how much we can refine our data as we go along. And then we need to train the model. Again, this is not something we do in business intelligence. Training a model is the next step from that. Once we have our clean data, we're trying to identify patterns in the data. And it's about the ways that Azure ML takes patterns in the data. That's going to be the focus of the session today. How do we know which patterns to use? So what we have then finally is a score model. How well did our model perform? And so that's something we're going to talk about as well as we go along. It's very easy to produce models in Azure ML, but what we find there is that the models may not perform very well. So how can we identify how well a model is performing? So without any further ado, let's talk about some of the models that we have actually seen in Azure ML. The first one that we're going to focus on is called regression. And what that really means is it's all about scoring the data and trying to make predictions from it. So let's have a quick look at the different types of regression. Now, the term regression itself stems from a 19th century statistician's observation that children's heights tended to regress towards a population mean in relation to their parents' heights. Regression is a measure of the relationship between the average value of one variable and corresponding values of other variables. If we are investigating one variable only, then this is a simple regression. If we are investigating more than one variable, then it's a multiple regression. What we have here is the difference between linear and curvilinear. Curvilinear is also known as nonlinear, and it's based on the constancy of the ratio of change between the variables. If the amount of the change in one variable tends to be a constant ratio to the amount of change in other variables, then the correlation is said to be linear. An example of that might be the relationship between height and weight. We usually find that if people are taller, then they weigh more. So what we're looking at there is a linear correlation. And if we plotted all of the variables on a graph of paper, then the plotted points would mainly fall in a straight line. If they do that, then we know we are looking at linear regression. If the plotted points don't fall in a straight line, then they are considered curvilinear. Now that's one way to make sure that you are really understanding the data is to visualize it. Visualizing data is so important because it helps you to see at a glance patterns in the data that you hadn't seen before. So here's an example of a linear regression. So what we have here is if you have a very simple regression such as the relationship between height and weight, a simple linear regression will summarize the relationship between the outcome and the single explanatory element. However, we know in real life things are not that simple. If we have something else, some variables in there, then they can be called a logistic regression. That builds a model of the data to make predictions, and it makes a summary of it. It's a scoring model, and basically it predicts a value between 0 and 1, so it's very good for predicting probabilities. So what it does is really summarize the variables, and it gives you estimates of parameters, what it thinks the variables, how it thinks the regression might actually work. It's possible to envision logistic regression as modeling the behavior of a coin tossed in the air. How will it land, in heads or tails? The outcome, or the probability of the results being heads, depends on other variables. The resulting predicted number is an additive function of the inputs. The resulting model also gives us an indication of the relative impact of each input variable on the output. So regression really means the unbiased prediction of the conditional expected value. If there's only one independent variable x, then that might predict a value y. So regression is a great starting place if you're just getting started with Azure ML. Doing some regression modeling on the data can be really useful for helping you to see any relationships in the data. So it's actually a great starting point. So one takeaway for you for doing data science is perhaps you should have a think about making sure that when you start down that path and you've got your clean data, that you actually do a regression on the data. So how do we know if our model is any good? So how do we know if our regression is any good? Well, what we do is we fit a model to the data set. Now, if you can imagine a dartboard like we have here, you see that some of the darts have not quite hit the bullseye. Now, we can relate this to finding out how well our model has gone. The difference between the bullseye and the hit is known as the residual. When we are working out the success of a model or not, what we're trying to do is work out the residuals. This is the difference between the actual value of the variable you're predicting and the predicted values created by the model. So what we're doing there basically is comparing the actual value with the predicted value and looking at the difference. So a good model, a good regression model, is going to hit the bullseye some of the time, but not all of the time. When the model doesn't hit the bullseye, a good model will miss hits in all of the other buckets evenly. We also expect a good model to miss closer to the bullseye as opposed to on the outer edges of the dartboard. So if the model is good, the darts will be closer to the centre rather than on the perimeter of the dartboard. So in Azure ML, we get some results, and some of those are called the residuals. And what that really means is, like I say, the difference between the actual and the predicted output. So we use those that actually worked out using the mean and the standard deviation. And that's computed separately for each column. So that really gives us some sort of shorthand in understanding the data that appears. So we've got min-max as well. Now what that really means is you can start to rescale your data. So say for example you've got data which is height and data that is weight. So if you find that there's quite a big range between the minimum and the maximum amounts, what you can do is scale the data, and it will rescale it between 0 and 1. And the idea there is we're trying to make the data a bit more neat in terms of how the data has been measured. Let's say, for example, you are measuring two things, height and weight. You might find that your height is measured in centimetres and that the weight is measured in stones. So, for example, someone who is 160 centimetres in terms of their height may be something like 8 stones in weight. So what we find there is there's quite a big difference between the actual height, which is the number 160, and the weight, which is the stones. So what we can do there is start to rescale the data, making both of the scales for height and weight actually mean the same thing, all of them between 0 and 1. And that can mean that the variations in the smaller size data set don't get lost because we are being unduly influenced by the data set which has the larger range. So that's what min-max starts to give you. Another type of model is an association rule. Now the thing with the association rule is that you will use this a lot without actually realizing it. So an association rule is a method for discovering interesting relationships hidden in large data sets. So what we'll do there is we'll have an association analysis, and it will search through a set of transactions. Now you may see something like this when you look in, I'm guessing most of you must be users of the Amazon website, and on the Amazon website you see that there are lots of associations between products you've already bought and the products that are suggested to you. You might see parts of the page that say things like, people who bought this also bought other items. So these are basically associations which are commonly found in business. They can be used for market basket analysis, which is something that we often see in online shopping websites such as Amazon. You may see websites that have a section that shows you the items that other people bought, which are related to items which you have put into your online shopping basket. Now here's a good British example. We have fish, chips and salt. We find that if somebody bought fish, chips and salt, then we might see from our data that they might actually buy a soft drink as well. They'll get thirsty from eating the chips and salt and the fish. So just to have a quick recap, we can see so far we have covered regression, which is all about scoring, and now we are looking at association rules. So association rules are not really about scores. They're more about the relationship between items hidden in large data sets. So we can start to see that Azure ML can be used for different things. It can produce association rules if you look at, and it can produce regression algorithms as well It already has a lot of inbuilt tasks for that already. So we can start to see our business question really starts to determine the type of model that we produce in Azure ML. So with that in mind, we are going to look at yet another type of model as well, and this one is called clustering. So what is clustering? So far we looked at regression and we looked at association rules. Now regression is trying to make predictions. Clustering, on the other hand, is more like association rules in that we are trying to find patterns in the data, things that go together. Clustering is a way of analysing data so that the items are grouped into similar groups or clusters according to their similarity. Before we start to cluster the data, we don't know the cluster where each data point resides. Clustering is an example of an unsupervised method of modelling data. In unsupervised methods, you're not trying to really predict an outcome. Instead, you're looking for patterns in the data. Using unsupervised methods means that you can take a fresh look at the data for patterns that you may not have considered before. There are two types of unsupervised methods, clustering and association rules. Clustering finds groups in the data that have similar characteristics. Association rules look for characteristics in the data that tend to go together. Here we'll look at a type of clustering called k-means. K-means is a popular clustering algorithm which is useful, is easy to implement, and it can be faster than some of the other clustering methods, particularly in the case of big data sets. What we see here in this image is that we see data being grouped into clusters around centres. The algorithm works firstly by choosing the cluster centres at random, and we see the cluster centres here in this diagram. Those are the bright orange stars. Then the algorithm works out the nearest cluster centre and arranges the data points around it. K-means then works out the actual cluster centre, then reassigns the data points to the new cluster centre, and it goes through this process until the data is filled around the various cluster centres quite equally. It tries to find the least amount of difference between all of the data points and the cluster centres. So we've put this into displaying results in R, but it also works in Azure ML. We'll see this in Azure ML. What we see here is something called a confusion table. We've got it here for R, but Azure ML does the same thing. A confusion table is a summary of classifier performance. It's a table that summarises the model's predictions against the actual known predictions. So earlier we had our example of the bullseye and then we had all of the arrows, all of the darts rather, scattered around the bullseye. So we had the difference between the actual and the predicted. The confusion table actually takes that idea. What it does is it calculates the known outcomes against the predicted outcomes. So what we see here is we're trying to work out the proportion of the data that are true negatives, false negatives, and true positives. So we're trying to get a balance. So now we're going to talk a little bit about neural nets, and I want to show you an example of how those actually work. We'll go through the Azure ML interface, but in the meantime, just to summarise before we move forward, we have looked at regression, we've looked at association rules, we've looked at clustering as well. Now regression is mainly about scoring. Association rules are more about the relationships that you find in the data. And then we have clustering, which is more about finding the patterns in the data and trying to group those patterns to make sense of them. Neural nets are actually very good for finding uncertainty in business questions, and that's why people get excited about them, I think. So in this topic, we'll look at unsupervised methods of analysing data, and we're going to focus specifically on neural nets. So neural networks are used in business to make predictions from a data set. Neural networks are one of the most interesting machine learning models. They are inspired by the structures of the brain. Neural networks are algorithms that mimic the functioning of the brain. We don't always know what the output should be, and they're best used for scoring problems or classification business problems. So we can use them for regression type problems where we're trying to predict a value, and we can also use them for classifying as well. Neural networks can actually be fairly time-consuming to run. However, with the power of Azure ML, we can start to leverage larger datasets and push the data processing to the cloud. Neural nets are complex because they contain many hidden layers, and that's what you see here in the purple box. The middle function that we see in the middle, marked by the purple box, maps the inputs to the outputs. To achieve this function, the neural network needs to undergo a lot of training cycles. Training a neural network model is an iterative process. It involves finding the weight values in a function, and that's located right in the middle of the network. When the model is presented with input data from the training set, the computed outputs should closely resemble the known outputs in the training data. Once the inner function has been worked out, the model can be presented with the test data in order to evaluate its accuracy. This will help us to understand how well the model will perform when it is given new data, and we don't know the true output results. In our example that we're going to look at in the demo, we're going to use a number of independent variables, such as age, education and gender, to predict whether the individual earns above or below $50,000 a year. So how do we know if our neural network is performing very well? We'll cover the evaluation of neural networks when we look at the demo. However, to make the concept of the neural nets a bit clearer, we are going to have a quick look at the receiver operating characteristic curve here. Now this is actually a screenshot from Azure ML, and what it does do is it tries to measure the true positive rate and compare it against the false positive rate. Essentially, the takeaway here is that if the closer this curve is to the upper left corner, the better the model's performance is. That means it is better at identifying the true positive rate while minimizing the false positive rate. So with that in mind, we'll have a quick look at creating a demo in Azure ML. So I'm just going to switch my screen a minute so that you can see it in Azure ML. Okay, I'm just double checking that you can all see that. There we go. Right, so I hope that's okay. Hope everybody can see that, no problems. So what we're going to do now is we are going to create a neural net using Azure ML. Now the first thing I want to do actually is rename my experiment. So I'm going to call it Azure ML webinar. So what we're going to do in this particular one is we are going to use people's characteristics in order to understand better if they are low earners or high earners. So what we're going to do there is the first thing we're going to do is import the data first of all. This is going to use the adult data set, which is actually available already in Azure ML. So what I'm going to do is type in the word adult here. We see here we've got a sample. Adult sends us income binary. Now what this gives us, and I'm going to run it just now so we can see the data, and we should be able to visualize the data. So let's have a look. So to visualize data, before we dive on actually, I want to show you some of the structure of Azure ML, how it hangs together. So what we've got here is in the bottom left-hand side, we've got new. So that's if you want to create a new experiment. Now when we create a data science component in Azure ML, it's called an experiment. And that is the end-to-end part of working with data. There we might import data, do something with the data, and then output it back out again. We can also run it as a service. So what we've got here is our data set, and I'm going to visualize it so we can see it. So this is our new experiment. Now here's the data. I want to show you that before we move forward. We can see here that the data has got the age here, and when we click on the age column, we can actually see visualizations here. So what we see here is we have got data. Some of it, this is age on the x-axis, and that's showing that we have a number of cases where people are considered to be over 75 years old. So we have a number of characteristics here in the data. We know the classification of work, we know their highest level of education, how many years they spent in education, we know whether they were married or not, their occupation, whether they're in a relationship or not, the race, the gender, we know how many hours a week they work, and also the native country, where they're from. This is the thing we're trying to predict, and that is the income. So what we're trying to do there is find out how many people are actually earn below 50,000 a year, and how many people actually appear as earning over 50,000 a year. So we've got our data set here. So the first thing we want to do is normally we might edit our columns, but what I want to do is remove columns that we don't need. So on the left-hand side here, what we see here is we've got all of our tasks. I'm just going to add this one here. So if we know the name of our task, we can type it into the search box. Or what we can do is we can start to look for the various tasks here. So we might see data transformation, for example, or we might see manipulation as well. Or what we can see, for example, is the ability to import text as well. We might actually also see time series. We can also import R as well. So if you already use R, you might find you can actually take your script and copy your script pretty much as it is into Azure ML. Now, just an aside, if you do use R, the power that Azure ML gives you is the ability to store large data sets in Azure ML. So instead of trying to work out how do you store as much data as possible into your data set, what you might find is you can actually store big data sources in Azure ML, and you can access those quite easily. So because if you run R on its own, what happens is you're limited to what you can actually use on the laptop in terms of memory. But if you use Azure ML, what you do there is really harness the big data and the processing power of Azure ML, and really expands your opportunities to use Azure ML to its fullest. So what I'd like to do is I'll show you how these are connected. So all I'm going to do is click on the source, and then I can drag and drop it from one task to another. So when I click on a task, you see at the right-hand side, we start to see the properties of that task. Now this element here tells me that I need to do something. So I need to choose a value. So which columns am I going to choose in the data set? So I'm going to choose all of them, apart from this one. Now the data itself was taken from the census data set, and this column here, final weight, is a very, very specific term used for the census data sets. So we don't want that. What I want to do is take all of the data columns across apart from that one. So I'm going to leave that one on the left-hand side. So we've got our data here, we've imported our data, then we've started to select the columns in the data set, we're starting to do some processing. Now this gives us a mini-map of how it appears. We'll see that change as we start to add in more tasks. Now with any data science project, the first thing you need to do is summarize your data. Now this gives you the descriptive statistics of the data. I'm going to squeeze that on the page so we can see it a bit better. So I want to summarize the data set. Now actually tasks can have more than one connector. So with the adult data set, I'm going to connect it to the summarized data task. And what the summarized data task does is it generates a basic descriptive statistics test on the data. Now so you can see that, I'm going to run it so you can see the results. Now that will take a few moments to run. If you're used to using Azure, if you're used to using integration services, then you'll find that this is quite similar in appearance, and the reason for that is the SSIS team were actually used to help create the layout and the graphical user interface for Azure Machine Learning Studio. So that's why they look so similar with tasks that you can drag and drop. So now we have got our data, we've summarized it using this task. Now we are going to create a neural net, but before we do that we need to summarize our data. So I'm going to click on the ball at the end, I'm going to click on visualize, and what we see here is that instead in our previous example we had all of the columns appear at the top, the columns now appear as rows on the left-hand side here. Now here our final weight column is still there because we have gone directly to the source, so it's still there. So interestingly enough, what we see here is we have the count of rows, we have the unique value count, then we have the missing value count as well. So this tells us how many values we're actually missing. So we see that the work class column was missing 1,836 values, and the number of values that had, number of rows that had a value in it was 30,725. So we see here that education is given for everybody, so there in total 32,561 rows of data, and none of the values are missing there. But we do have missing values for work class. We've also got them for occupation down here. And then we've got native country as well. So we've summarised our data, so that tells us that we have missing data. So that's something that concerns us a little bit. So then what we want to do next though is remove duplicate rows from the data set. That means that we're going to remove any rows that are missing data as well. So let's remove duplicate rows first. So I'm going to connect select dataset down to remove duplicate rows. So we can see here that we've got a value again. So let's look in our properties box. What we have there is the launch column selector box. We see none of our columns are missing from here. So we want to check basically, are all of these columns actually missing data or not? So we're going to select all of those, see if there's any duplicates. Then what we can start to do there is think about removing any rows that have got missing data. So to find the tasks that I'm looking for, we can see here there's a clean missing data task as well. So we have duplicate rows and then we connect it to clean missing data. So we can see the experiment is starting to get bigger. I'm just going to move the map because I don't need that anymore. What we can do then is actually check our experiment before we move any further. This is something you're probably used to doing with SSIS and with other technologies as well. So let's see how our data looks as we go along. It's working on removing duplicate rows, and it's going to clean missing data. So how do we know that our experiment is actually finished? We can see here at the top right hand side it says finished running and gives us a green check mark. So when we remove the duplicate rows, let's see what happens here. So now we've actually got less rows than we had before. Instead of having, now here we've got 29,303 rows and 14 columns. Our original data set, which we can see from when we summarised the data, was that we had in total 32,561 rows. So actually we found some duplicate data in there. Duplicate data is difficult and dangerous for modelling. What we find is that it takes up more disk space, so things take a bit longer. It can also mess up your results. So that's why we get rid of duplicate rows. Then we'll look at our missing data as well. So we visualised that. Here we were going to remove any rows that had data missing. So what we see here is actually we've now got 29,303 rows. So our data sets have started to get smaller as it gets more clean. So the duplicate rows and the missing rows have actually reduced our data set a little bit. So once we've cleaned our data, we also want to remove outliers from the data as well. So I'm going to do another search for outliers, and that's called clip values. So I'm going to clip values, pick that task, and move it here to the canvas. And I'm going to connect our clean missing data task with the clip values task. I'll make this a bit smaller so it appears on the page. So now I click on clip values, and what we see there is we can clip the peaks of the data, or we could clip the peaks and the sub-peaks of the data. Now, what we want to do is a constant value of the upper threshold. Now we're going to take the age at this point, and we're going to cut out data points where the age is over 75 years old and where the age is less than 18. So in other words, we're just going to consider the working population when we analyse our data set. So the constant value, the upper set, is actually going to be 75, and the lower value, the threshold, is going to be 18. And that's just going to apply to numeric data, and in fact we are just going to include that with the column name. Now this is a column selector, and we get some options here. We could apply that to every single column that has a numeric data type, but we're going to restrict it to the column names. I'm going to choose that option, and we're going to restrict it to age. So basically what this clip values task does is if it finds any rows where the age is over 75 or less than 18, it's going to exclude them. So I'm going to save my experiment, then I'm going to run it again. This takes a little bit longer to run, but not too much. So we see our clip values. Now if we click on that and visualize the data again, we're going to see how many we've got. So what we've got here is 29,303. If we click on the age column, we can see here that our minimum is 18 and our maximum is 75. So we know that our clip values is worked. If we go back for a moment to the adult census income binary, we can visualize that data as well. Go back to the start just to compare it. If we click on age here, we can see that the minimum age is 17 and the maximum age is 90. So we've started to move the min and the max. So we're going to clip our values. Okay, so now we've clipped our values. We have some data that's fairly clean. What we've done is we've removed duplicate rows, we've removed missing data, we've also clipped outlier values from the data. So when we've completed all of these steps, what we want to do now is split our data into a test set and a training set. going to type in the split here, and this is going to split our data. So I've connected clip values and split data together, and what I want to do here is split our data. I'm going to use 70% and 30%. Now it comes up as a decimal, 0.7 being 70%, and what that means really is that 70% of the data is going to come out of the first node here, and 30% is going to go out of the second node here. So what I want to do now is create a model, and then we can train it. So I'm going to type in the word neural, and the one that we are going to look for is going to be called two-class neural networks. So that tells Azure ML which type of model we want to use. So what I'm going to do then is I'm going to tell it that we need to train the model. So what we're going to do there is again look for train model and connect it to the type of model that we want. Now if you click on train model, we need to keep the flow working. So what that tells us is that we want 70% of the data to go towards training the model. So this point is an untrained model, and then we've got the data set coming into the left-hand side here. Now we see that train model is looking for a value again, so we're going to click on that, and it really wants to know which one is going to be the income, which one is going to be the end result, as it were. So when we're training the model, it's going to be income, because our business question is all about identifying high and low earners. So we've got income here. So what we're going to do then is add in a score the model task. Type in the word score here at the left-hand side. So the results of the trained model will feed into the scored model here. Now to score a model, we actually need test data to do that. If this was in real life, we'd most likely have it at different versions of the data set, but for the moment we're just going to stick with the same one for simplicity. So we've got the train the model, then what we do is we can score the model, then we can evaluate it as well. I'm going to drag and drop evaluate model. So I'm going to run that experiment. It should take a little bit longer at this point. But what really we've done is we've followed a process of importing data, cleaning data, modeling the data, and then we can look at the results that it gives us. We can see here that Azure ML is fairly fast. We didn't create a neural network for ourselves. We used the one that Microsoft created themselves, which is the two-class neural network. What's nice about that is I've been able to create an Azure ML experiment very, very quickly. So if you try Azure ML, you can get yourself up to speed with it fairly quickly. There is a gallery of examples that you can use in order to do that. But what we've got here is the model's been trained, it's been scored, and then it's been evaluated. So let's have a quick look and see how our model is done now. So we can click on each of the tasks. So we can visualize our neural network and see how that looks. So we don't need to go into this in detail. There's plenty of help files for you to do that. But what we can see here, it's gone from min-max. So it's tried to normalize the data by turning it into zeros and ones. Neural nets will do that for you. Not every type of algorithm will, but neural networks will. Best way to identify whether you need to do that for yourself or not is have a look at Azure ML and books online. So what happens when we train the model? Let's visualize it. So what we can see here is it gives us some details about Azure ML itself and the neural network. It did 100 passes through the data to get the results. Then we can score the model as well, and this is usually the interesting bit. And it's interesting because we see what results we actually got. So this is how the data was scored. So we can see here that income was 50, less than 50,000, and the scored labels column is the one that we're really interested in. That's the one where it thinks that's what the answer should be based on this data. So we can see here in most cases it's got it right, it's got a fairly good example. So we can see here the scored label is 50 less than 50,000 or over 50,000. There's two unique values, which is over and above. So what we can see here is the scored probabilities as well. We can see the min and the max is basically between 0 and 100% how certain it actually is. So we can see that it's done well here in terms of the scored probabilities. So let's evaluate the model. We can do that most easily just by visualizing it at the end. So what we see here is that the model is the receiver operating curve actually takes the values that the model has produced, and what it's tried to do is try to work out a comparison between that and the best guess of the data. And basically, at a very high level, this chart starts to tell us how well the model has performed. So what this tries to work out is working out two measures called precision and recall, and when we scroll down, we can see that the results are actually based on these two figures here. Precision, 70%, and we've got recall, which is 50%. So together, these two numbers give us what's known as an F1 score. So a high F1 score would be closer to 1, and that would tell us how effective the model is in determining how precisely it identifies the model, how precisely the model identifies the data as being above higher earner or a lower earner. And it covers a good proportion of the cases that it should have classified correctly. So we can see the positive label is over 50, the negative label is less than 50. So these here, the true positive, false negative, the false positive and the true negative, they actually form our confusion matrix. That tells us how many the model got right, and it tells us how many the model got correct. How many false positives we got? So we got 500 false positives nearly, 478. And we get a number of false negatives as well. And that tells us actually that scored quite highly, identified a lot of people as being in one case when they should have been in the other. So the overall accuracy came up as 83%. So what we look at this one is to say, well, actually we might want to do more passes of this model to identify if we can make it any better. We can also change the thresholds as well. So if we increase our success threshold, then what we can see is that gives us slightly different examples. So the threshold is how correct do you want it to be. So if a threshold is 0, then it's only accurate 25%. There's not that much difference as we move that forward. So to summarise, in this session, we've looked at different types of models. We looked at regression, which is for scoring. We looked at classification and association algorithms, classifying data and using association rules in order to work out relationships and characteristics that we see within that data set. Looked at neural nets, and neural nets are most interesting because they're actually inspired by brain function. They mimic the functioning of the brain, and they are unsupervised algorithms. We don't always know what the output should be. They're complex because they contain many hidden layers, and basically what the middle function does is it maps the inputs to the output and works out the equation to try and give us the best results. So we can see that Azure ML gives us a ton of features. The ability to import data, it gives us the ability then to clean that data and understand more things about it. Then it gives us the ability to model that data. And then once it's modeled the data, it can then work out how accurate the model actually was. So really with that in mind, we've reviewed neural networks in some detail. We could find out some more details for this one. So we visualised that. We just looked at the receiver operating curve. I want to show you the other ones as well. This is precision and recall, and that really is trying to work out how many times it got right versus how many times that it got incorrect. So how precise it was determined by the number of times that it was correct. And then the lift chart. And the lift chart visually represents the improvements that this module provides when compared against a random guess. It's called the lift score. And with the lift chart, you can compare the accuracy of predictions for the models that have the same predictable attribute. So all that's doing really is trying to calculate the number of true positives, and that gives you the positive rate. So with that in mind, I'm just going to look and see if we have got any questions. Just going to double check. No, with that, I think we are finished for this for today. So if you have any questions, please don't hesitate to get in touch. My name is Jen Stirrup. Thank you for joining me today. I hope you enjoyed this session in Azure ML. There's so much to cover here in Azure ML, so that was a very quick flying tour. And with that, I'll hand over to you.
Thank you so much, Jen. And once again, thank you everyone for participating. Hope you have a great day. Bye-bye.